All right, our lesson is factor a difference of squares. Recognizing a perfect square or thinking of a number that when multiplied by itself gives you that number. So we have, for example, down here, well, 9, we know that to be 3 times 3, so which means that the square root of 9 is equal to 3. 16 is 4 times 4, or the square root of 16 is equal to 4. Or a variable in this case, x squared is equal to, well, x times x. That's how you would get x squared. Or therefore, we're writing it as the square root of x squared is simply equal to x. The square of a number is that number multiplied by itself. Recognizing a difference of squares. So for example, expand the following binomials. So we have x plus 3 and we have x minus 3. Our expanding is using our FOIL, first, outside, inside, last. So x times x is x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. And then 3 times negative 3 is negative 9. Now you'll notice that the like terms here, negative 3x and 3x, cancel out. Negative 3 plus 3, those cancel out. So you're left with x squared minus 9. So what happened to the middle term? Canceled out. What do you notice about the remaining terms? That they are perfect squares. So what that means is that if I square root this, let's draw it in here. If I square root x squared, and if I square root, it's terrible square root, 9, I get answers, or I get actual whole numbers, right? So I can square root both of them. So both terms in the binomial are squares, and the operation between them is subtraction. So the only way to identify a perfect square is with the operation of subtraction in the middle of them. So if I just quickly expand on this, x plus 3 multiplied by x minus 3, so you have a positive and a negative value, you're going to get a perfect square. What happens if they aren't opposite signs inside the binomials? So for example, we have x plus 3 multiplied by x plus 3. Well, if I follow my FOIL laws, I get x squared plus 3x plus 3x plus 9. And then my like terms of 3x are added together. They don't cancel out because it's 3 plus 3. I end up getting 6x. And then 3 times 3 would give me 9. So yes, this is a perfect square. This is a perfect square. But then that middle term is not a perfect square. So in order to have difference of squares, the binomial must contain a subtraction sign. So if we just kind of go back down here, factoring a difference of squares. To factor a difference of squares, we identify the squares and write them as two binomial factors with opposite signs. So example 1, factor each of the following. We have x squared and we have minus 25. So this term, x squared, and this other term, 25, is separated by a subtraction sign. So if I square root x squared, I get x. If I square root 25, I get 5. And then I'm simply writing into the framework of something plus multiplied by something minus. So they went ahead and go put in x, well, I get an x for both, and I get a 5 for both. That was where we got these from, right? And I just simply brought those down into the expression. Again, a good way to check to see if you did it right, if you were to go ahead and expand those back out using FOIL, you would get this as your final answer. I'm just going to go for example C here. I won't do all of them. X squared minus 100. Take both terms, square root them, and then factors with two opposite signs again. So my framework that I'm going to be plugging in values, one's going to have a positive and the other is going to have a negative. So square root of x squared is x, square root of 100 is 10. So what I'm doing is I'm basically putting in my x and then my 10. That's what I figured that out to be, right? Again, if you go ahead and expand that out, you'd be able to tell, or you'd be able to come back to the same original part of the equation here. Example 2, the diagram below shows two squares. The large square represents a concrete slab. So this part here is a concrete slab. The small square represents a storage shed sitting on top of the concrete. So this is a storage shed here. Write an expression that represents the difference of the areas of the two squares. So the area of this and the difference between that and this one. The area of the square is length times width. Okay, so the area of the large square, right here, side length of x, this is the same side length of x as well, indicated by those hash marks. So x times x gives me x squared. The area of the small square, well, I know that's 2, this is also 2, so 2 times 2 gives me 4. So the difference in the areas, this is the area of one, this is the area of the other. So the difference in the area is x squared minus 4. What does the difference in areas represent? Well, it represents the remaining concrete once the shed is removed, right? So if you have this concrete slab, you take this off, you pull it away, you have an area that remains. So if we factor the expression, square root of x squared is x, square root of 4 of 2. Therefore, we're plugging into our binomials that are being multiplied together, x plus 2 and x minus 2. Right, so this is what we started off with. We took a square root here and a square root here. We found it to be x and 2, and we just plug it in to our multiplication of binomial. Third example, the area of the top of a classroom art table is represented by the expression x squared minus 100. Okay, so that's the whole area there. If the length is represented by x plus 10, okay, find the expression to represent its width. So the area is equal to x squared minus 100, which we know to be, if we were writing that out, x plus 10, x minus 10. Well, x plus 10 is the length, so what this means is x minus 10 has to be the width. Find the actual length and width if x is equal to 15 feet. It's a big table. So our length, x plus 10, which is here, right? Or 15 plus 10, because we know our value for x, they gave it to us. 15 plus 10 is 25. So this whole piece here, or this whole length is 25. The width would be x minus 10. X is 15 minus 10 would give us 5 feet. So this would be 25 feet, and this would be 5 feet. Calculate the area of the tabletop. So again, area is equal to length times width. So we know the length is 25, the width is 5. 25 times 5 gives us 125 feet squared. So big takeaways from difference of squares is that once you identify the terms, I should come down here. Once you identify the terms and you can square root both of them, you're just plugging them into this framework here. Whatever you find the first term squared by, if you square root that, you put that there and here. And that second term, you take the square root of that term and you put it here. And both of these are separated by an addition and a subtraction sign.